Okay, so this is just a quick video on addition formulas and double angle formulas. First of all, let's have a look at the two ones that you're given in the exam, which is sine A plus or minus B and cos A plus or minus B. Fully aware still haven't proved this. I will get around to proving them at some point. It's not something that you should worry too much about the proofs. It's obviously nice to know how things work, but it's not going to be examined. Then there's a whole bunch of stuff that either you memorize or you figure out how to do on the hoof in the exam. Now, as I've said to you about 3 million times, I've never bothered memorizing anything, that's why every so often I do something spectacular and get one of the signs wrong. Maybe that's not the best advertisement for working out every single time, but I honestly think that's the best way, because I think, by the time you get to the end of second year, you will have so much in your memory that your head will probably want to explode. So anything you can do there to shorten or lighten the load of things you have to memorize has to be a good thing in my mind. Anyways, enough preamble. How do you get tan? Well, it's just sine over cos, okay? So what you do is for tan A plus B, write the formulas for sine A plus B and cos A plus B, the ones you've been given, and then divide through by cos A cos B. And that will give you tan A plus or minus B, 1 minus or plus tan A tan B. Remember how the signs work. If you're doing a plus, go with the top things. If it's a minus, so for example, if it's tan A minus B, the formula will be tan A minus tan B, 1 plus tan A tan B. Quite much of the same thing. This time the only difference is it's obviously going to be cos over sine to start with, and you divide by sine A sine B. Now, the clever ones among you, and I'm surprised nobody actually said this in the lesson, said why not just flip the tan formula? Because obviously cot's the inverse of tan. Well, say that's true, and that would actually work. But in general, you want a formula for cot, which is about cot, and that's why it's done the way it is done. Okay, so that's why if we just flip the tan formula, you'd have a formula with tans in it, and we want a formula with cot in it. So that's why that is the way it is. So there's your formula for cot. You can also double up and make the double angle formula. So what's a double angle formula when it's at home? Instead of having A plus B, imagine both the things were just A's. So sine A plus B becomes sine A plus A, which will be sine 2A. So if it was A, it'd be sine A cos A plus cos A sine A, which is the same thing, 2 sine A cos A, and much the same way you can get a formula for cos 2A. In fact, you can get 3. The first one's just the obvious one. If you've got cos A minus sine A sine A, you've got cos squared A minus sine squared A. But then you use sine squared plus cos squared equals 1, a rearrangement of those, to either replace for cos and sine, and you've got 2 brand new formulas here. Okay, so that's where the second and third formula for cos 2A comes from. Similarly with tan A, it's just a matter of substitution, and cot A also a matter of substitution. Replace A plus B with A plus A, and see what you get. Hopefully that's not too bad, and you've already got the notes, but it's there anyways. Bye.